Welcome to RGES Pre-Algebra. This is Lesson 7B, and it is talking about percents, and we'll be reviewing all the ideas about percent that are in your textbook. First off, when you are writing at home to take your notes, I want you to label it with this title, and everything that's in black I want you to copy onto your notebook page. So percent means part of 100. So 25% can be written as a fraction, 25 over 100. It can also be written as a decimal, 0.25. Recall that if we're writing a number as a decimal, we would take the number. We would take the number, say 25, and if we're trying to do that number over 100, we're going to move to the left. The same, if we're dividing by 100, there are 2 zeros in 100, so we're going to move to the left 2 places. That's a point. Okay. It can also be written as 25 to 100 as a ratio in its more technical format, but we will not be using that as often. Recall that 100% means 100 over 100, or written as a decimal, 1. So if we say 100% of anything, it would be the whole amount. For instance, 100% of 17 would be 17. 100% of 234 would be 234. So the first goal would be to be able to convert decimals to percents. So if I give you, and again, I want you to write this also on your notes, if it's in black. So to move from a decimal to a percent, I'm simply going to move the decimal point 2 places to the right. So if I have a decimal, 0.63, to make it a percent, I'm going to move that decimal place over 2 places, and that will be 63%. It's like the opposite of what we just did above. So the next one, 0.09, moving the decimal place over 2 places, you get 9%. And if I get 5.29 as a decimal, and I want to convert that to percent, that would be, so if I say 5.29, that would be 529%. So I would want you to be able to go from the left to the right and from the right to the left. Convert in both directions. Now the second skill would be to be able to convert a fraction to a percent. And you want to, the technique is to change to a decimal first. So my first example would be 4/5. Now this is where that chart that you memorized on page 38, where you're converting common fractions to decimals, make sure you have that memorized. So 4/5, you should know already, is 0.8, but I need to move it over 2 places, so that would be to the right, so that would be 80%. So you're moving it from the fraction to the decimal to the percent. Let's try another one. 5 1/4. Okay, so write this as a decimal, and you would get 5.1/4 is 25. So that conversion should be easy to you. And then now, to make it a percent, I move the decimal point 2 places to the right to get 525%. Notice any percent over 100 would be much larger. For instance, 100% of the number 5 is 5. So 200% of the number 5 is 2 times 5, or 10. 300% of 5 would be 3 times 5, or 15. So make sure you understand the idea. Now, what if we had something like this? If we had 17/20ths. Well, there's a couple different ways you can do this. Method number 1 I would kind of think in terms of a proportion. I want to know what that is over 100 as a fraction. So this would have to be multiplied by 5, and so this would have to be multiplied by 5. That would be 50 plus 35 more, or 85. So if I could do it that way, that would be the easiest. I've got it now still as a fraction. I want to write that as a decimal, and I want to write that as a percent. Now, if I did not have something that was clear to me how it converted over, I could always say 17 divided by 20 and do it the long way to get my decimal. The third skill you need is to be able to take the percent of a number. In other words, if I had the question, 20%, what is 20% of 45? Well, 20% would be 20 over 100. So there's two methods. Method 1 would be the proportion method. 20% of 100, or 20%, that's the 20 over 100. There's the percent right there. 20% of 45. 45 is representing the larger amount, and I want to know what the smaller amount is. So I would do cross multiplication, and I would get 100x equals 20 times 45. That would be 2 times 45 is 90, and one more zero is 900. Divide by 100, and x equals 9. So if I have the number 9 out of 45, that's 20% of 45. Okay, so that would be my answer that way. Now, there is a second method, and that would be to do it by the decimal method. The decimal method would say change 20% to a decimal. Remember, we've taken the decimal point 2 to the left and multiply that by 45. You'll get the same answer. 45 times 20 is 900, and I would move that decimal over 2 places because it's got 2 places here, and so that would be 9. So you get the same answer either way. You may use whichever method you prefer. Now, the fourth technique that you need to understand is how to deal with percents less than 1. Let's say I have 1/4%. Well, 1/4%, what is that? Remember, I'm going to change to a decimal. I would first write the 1/4 as a decimal, 0.25, but I still am dealing with percent. And to deal with the percent, remember that means divide by 100, or over 100, so I would move the decimal point 2 more places to the left. So if I wanted to find 1/4% of a number, I would have to multiply it by 0.0025. Let's do another one. If you have 5 1/2%, and I want to ask you to find 5 1/2% of 50. Well, my preferred method would be to take 5 1/2. 1/2 is 0.5, so 5 1/2 is 5.5 over 100. That's the percent part. And I could do that as a proportion is the same as what over 50? Well, notice to get from 100 to 50, I'm dividing by 2. So up here, I would have to also divide by 2. And 5.5 divided by 2 is going to be 2.75. Now that was one method, the proportion method. The second method would be to take 5 1/2%, that would be 5.5%. That's writing the fractional part as a decimal, and then taking into account the percent, that's to divide by 100. So as a strict decimal, it would be taking it 2 places to the left, 0.055, and multiply that by 50. And you would get the same answer. Ignoring the decimals for the moment, I would say 5 times 5 is 250 plus 25 is 275 with the trailing 0. And now take it over 3 places to the left because of these 3 decimal places. And so I would have 2.750, which is the same. Trailing zeros, of course, never mean anything. So I could have 2.75, same answer, either technique. Okay, what if we talk about percents over 100? Again, make sure that you're writing all of this in your notes. 256%, even though now it's over 100%, it doesn't matter. I'm doing all the same technique. I'm going to write this as a decimal by taking the decimal point over to the left 2 places, and I get 2.56. Notice, if I'm taking that and multiplying it by anything, that would be greater, or more than twice as great as the original number. What if I had 300? You should know these by now, because they really haven't changed at all. 300, we're going to deal with that first. We're going to write that as 300. 1/2 is written as 0.5. We're going to move our decimal 2 over, and this is 3.005. And that would be my multiplier as a decimal. What if I had 360% of 270? Now this way I have both techniques open to me when I'm trying to find it of a certain number. So let's write those out. You try to put it on pause and write them out by yourself and see if you can do those two. So talking this one through, hopefully you did it, whichever method you chose. In method number 1, I converted it immediately to a decimal by moving it over 2 places to the left, my 360 to 3.60, then multiplied by 270. In my next one, what I did was I used a proportion, 360 over 100, because that's what percent means, equals what over 270. Cross multiplied, you get 100x equals 360 times 270, and then divide by 100, giving you 972. Now let's move on to the next concept. The next concept is discussing more or less percent, and the technique is to adjust from 100% by adding or subtracting. What do I mean? If you have a new price and it's 35% less than the original price, I would say, okay, that's 100%, that's the original, minus 35, leaving me with 65% of the original. So then I would take 0.65 and multiply it by the original price. If you said 20% more, then you would take the original price, let's say it's $70. Let's not even bother with that. The original is always going to be 100%, and now I'm going to add 20 more, and so this would be 120% of the original price. If the original price were $70, I would say 1.20 or 1.2. I'll leave the O, but it doesn't matter. 1.2 times 70. And that would be the new price. Again, to work with more or less in percents, if it's less, you subtract it from 100%, giving you your new percent value. If it's 20% more, for instance, you add it to 100%, giving me my new percent value. And then you go from there, either using your proportion method or using your decimal multiplier. Now, 7 is a key idea. This is when we're working percents with proportions. You've already seen this, but this is a very versatile concept. And this will be what's talked about in both 1.35 and 1.37. Percent with proportion. If you get the basic idea, you can use this to solve all kinds of percent problems. We have the small number over the large number equals the percent value over 100. Okay. So using this basic scheme, I can solve all kinds of percent problems. For instance, 18 is what percent of 60? How would I set that proportion up? 18 is the small number, 60 is the large number, and I don't know the percent, and the percent part is always over 100. Cross multiplying, you get 60x equals 18 times 100. You get x equals 18 times 100 over 60. I like to wait to do my multiplying till I brought the division over, because 6 goes into 18 3 times, 0 cancels out with one of those zeros, and now I get for my answer x equals 3 times 10, or 30. So it's much easier to do the arithmetic if you wait till the end. So 18 over 60 is 30%. Okay. So that's one way to use that. Let's go on to the next problem. 12 is 15% of what number? Remember, I'm looking for a small number, a large number, and a percent. Well, I have my percent, so the 15 would go over the 100. Is 12 the small number or the large number? By the way this is worded, it's the small number. So if you can figure out how to plug in your values and which one needs to be your variable, this will always work for you. Again, cross multiply. 15x equals 12 times 100. X equals 12 times 100 divided by 15. Recall, to bring that 15 over, you need to divide on the other side. I see that a 3 goes into 12 4 times, and a 3 goes into that 5 times. I see 5 goes into 100 20 times, and my answer is 4 times 20, or 80. You see how canceling can be so very useful to you. Does it make sense? Is 12 out of 80, so this is my answer, is 12 out of 80 15%? Well, let's think, how would I think this logically? What's 10% of 80? 8, okay? 8 is 10%, and so would it make sense that 12 would be 15%? Yeah, I would add half again as much. So you kind of do a little eyeball check to make sure that you're thinking in the right track. Now let's do another question. By the way, that last problem was the kind of questions you would have in 1.37. Now this is a review from 1.31. We showed it to you before, but now let's use it with our proportion method. We have what number is 8% of 500? Well, what is the small number? What's the large number? 500 is the large number, and I do not know the small number. That's what I have to figure out. My percent over 100 is the 8. Cross multiplying, I get 100x equals 8 times 500. I'm going to divide by 100. My zeros, 2 zeros will cancel there and there, and I'm going to be left with 8 times 5, or 40. Is it logical to you? Is 40 over 100 8%? Well, how would I think that through? 8% is a little less than 10%. What is 10% of 500? Well, 10% would be, going over one place, 10% of 500 is 50. And so I want something a little less than that, and that's a 40 is a little less than that. So that's very logical to me. We only have one more concept to cover. 1.36 talks about percent of increase or decrease. We often see this in prices. So we're going to always put the new value, or no, that's not true. We're always going to put the change in value over the original price. So let's say, my first example, if I had 18 and now I have 21, doesn't matter what I'm talking about, okay? The change is an increase of 3. So I'm going to put the 3 over the original value, 18, and I'm asking what is that as a percent. Well, there's a couple ways you can figure that out. One is you can say a proportion. So 3, let's do my x on the left side. 18x equals 3 times 100. X equals 3 times 100 divided by 18. This is why I like to save my arithmetic, because 3 goes into 18 6 times, and now I have 100 divided by 6. If you wanted to divide that out, you could, or you could say that 2 goes into the top and the bottom. Okay, so we got 50 thirds. Okay, and then we could divide that out, and you're going to get 16.6, or if I rounded it to the nearest whole number, I would get 17 what? 17%. 17% increase. Okay. Now that's one way I can do it. Now another way you could do the same problem is you could say, so this is just a second technique. Rather than using a proportion, I could just start with my original fraction, the change in value over the original value. Simplify that. 3 goes into 18 1/6, and you recall that 1/6 as a decimal is what? 0.16 repeating. You remember that from your chart? So then again, I would have, if I rounded that, that'd be like 0.1666. If I rounded it to 2 places, I would have it 0.17, and that is again 17%. Okay, and I have increased it because I went from 18 to 21. Let's give you a couple more problems of this variety. What if you have a second problem and it says that you had 35, but now you have 28. Let's say I was making $35 an hour, but now I'm making $28 an hour. Notice I have gone down, and the actual amount I've gone down is 7. So I would put the change in value, the 7, over the original 35, and I would convert that to a percent. Again, 7 over 35 is the same as 1/5, and 1/5 is 20.20, and if I convert that to a percent, that is 20%. Okay, so this is a 20% decrease because I've gone down in value. So hopefully those are all clear. That's really the whole, everything you're expected to know about fractions. The big idea then is when I'm going from a fraction, Okay. To a decimal, to a percent. When you're going from a decimal to a percent, you are moving the decimal point to the right 2 places. When I'm going from a percent to a decimal, I am moving the decimal point to the left 2 places. Okay. If you can just remember which is larger. If I have 0.36, that's the decimal. The percent is 36. Okay, so this is going to be larger, the larger value. Okay, so I think that's all you'll need to do those problems. That's section 1.36.